Hello everyone, myself Professor Rutuja Jadhav, Assistant Professor from Computer Engineering Department of KK Wag Institute of Engineering Education and Research, Nasik. Welcome to the E-Series lecture on Theory of Computation, course of third year Computer Engineering of 2015 pattern, and the topic that we are going to study today is context-free grammar. So let us begin. So these are the contents of discussion. First we will see the introduction, then context-free grammar definition, derivations, language of the grammar, sentential form. The objective of today's session is to understand the concept of CFG and secondly to understand the derivation of strings from the CFG. Outcomes: after this session you will become familiar with the concepts of CFG and also you will be able to derive a string using grammar rules for a given context-free grammar. So let us begin. So basically, what is grammar? So grammar for a particular language is defined as the finite set of formal rules for generating syntactically correct sentences. We can also say that grammar defines the syntax of a language. Consider an example. Suppose we want to generate the English statement dog runs. So we will be using the following rule as shown on the screen. Sentence is equals to noun followed by verb, where noun is nothing but the dog in this case and verb is nothing but the runs in this case. So there are certain rules. So there are many rules like this in the language and these rules collectively are called nothing but the grammar for the language. Now let us see the formal definition of the context-free grammar. So basically there are four important components in a grammatical description of a language. Firstly, there is a finite set of symbols that form the strings of the languages being defined. So here you can see the set consisting of 0, 1. So these are nothing but the set of symbols and the string formed with the help of these symbols is 0, 1, 0. So here this is an example of a palindrome. So here first component is the set of symbols, which is also called as the terminal symbols. Okay, so these are the symbols with which you can form the strings. Okay, then secondly there is a finite set of variables also called as the non-terminal symbols or syntactic categories. So in our example, if we say P is the variable which represents the class of palindromes over the alphabet 0, 1. So we can say P is variable is nothing. Variable is the one which represents the class of the language. Okay. Then next is start symbol. So one of the variable represents the language being defined and that is called as the start symbol from which the production rule begins. So start symbol and the remaining variables then are called as the auxiliary classes of the strings that are used to help to define the language of the start symbol. Okay, and finally the fourth one is the set of production rules or rules you can say. Okay, so what are rules? So that represents the recursive definition of the language. So there are four important components put together: symbols, variables, start symbol and the production rules. So all four together forms the grammar. Further, now this production rule consists of the head of the production, that is from where the production rule will begin. So suppose P gives A is a sample production rule where capital P is the head of the production. Secondly, production symbol, as I have said, P gives, so arrow, so production symbol is used. And finally the string of 0 or more terminals or strings, that is the body of the production. So if we put all four components together, this is what we write the definition of the grammar. G is equals to V, T, P, S, where V is the variable, T variables are nothing but the non-terminal symbols and T is the terminal symbols, P is the set of productions and S is the start symbol. So let us see one example of CFG of the palindrome. So here the grammar is represented as G is equals to P 0, 1. So P is the variable which will be used in the production rules. 0, 1 is the set of symbols from which the strings will be generated. A is the set of production rules and P is the start symbol. So these are the set of production rules and P is the start symbol. So the rule starts from P gives epsilon, or P gives 0, or P gives 1, or P gives 0, P0 because it's a palindrome, and P gives 1, P1. So this is the sample example of the CFG for palindrome. Now let us see the derivations using grammar. So there are two approaches to infer that the strings are in the particular language. So first is recursive inference and second is derivations. So let us first discuss recursive inference. So basically it is a conventional approach. It uses the rules from body to head. So let us see the example of recursive inference so that it will be more clear. So consider the grammar. So here grammar G1 is given as E gives I, or E plus E, or E into E, or parenthesized E. Further, I gives A or B, or IA, or IB, or I0, or I1. Now suppose we have to infer the string A into A plus B double 0. So here the last one you can see over here. Suppose we want to infer this particular string from the given grammar. So how we will proceed? So one by one we will be exploring. So first we will be maintaining a table like this. So where here is the first column is string, second column is the language, next is the production rule number and strings used. So for our understanding, so this is production rule 1, this is second, third, fourth, fifth, sixth, 7, 8, 9 and 10. So 10 production rules are there. First there is E language as well as there is I language. So if we want to generate the string A, so we will be starting from body to head. Okay, so body means the terminal symbols and head means the start symbol we have to reach. Okay, so we will be starting with A. Okay, so A, from which language we will get A? From I language. And by which production rule? So I gives A. This is the fifth production rule. Have you used any string for it? No, so dash. Next B we have to generate. From where we will get? So we will get from the language I. Which production rule you have used? The sixth one. Have you used any string? No, so dash. Next we want to generate the string B0. So from where we can get that? So from the same language I, and the production rule is 9. Have you used any string? Yes, we have used B and then we have attached B0 to it, appended 0 to it. So the string used is second. Similarly now we want B00. So B00 we will make use of the string third one. So that is why third. Again it is derived from the language I and the production rule used is 9th. Then next, from where we have got actually the A? From I, right? But from where we have got I? So we have got I from E. That is why the language over here is now E, because we have to ultimately go to the head. Okay, so E. Which production rule you have used? The first one. E gives I. So I. So 1 over here. 1 over here. Have you used any string? Yes, the first one. Then next B00. Which string we are using? The fourth one. So here fourth. From where we have got B00? From I. But from where we got I? From E. So again it is the first production rule. Now next we have to form the string A plus B00. So A, fifth and sixth strings are combined. So fifth and sixth strings. Now which is this production? This is of the type E plus E. So the second production rule from the language E. So that is why over here language is E and the production rule is 2. Now next it is parenthesized A plus B double 0. So which type of rule? Again it is parenthesized E. Okay, so it is of the language E and the production rule is 4. Which string you have used? The earlier string, that is the 7th string. And finally our string, that is A into A plus B double 0. This is the string we are interested in inferring. Yes. So from where you have got this bracketed is nothing but A into A plus B double 0. So which production rule it is? So E into E. Okay, so from language E, the third production rule. So that is why E and 3. Which strings you have used? The 5th one, that is A, and the 8th one, that is A plus B double 0. So in this manner we have inferred the string A into A plus B double 0, okay, using the recursive inference example. That is from the, we started from the body and we have ended till the head. So hope it is clear. Now let us see the second type of derivations, that is the derivations, which is the reverse of the recursive inference. So here we will be using the productions from head to body. In earlier we have used the productions from body to head. Now we will start from head and we will go to body. Okay, so there are basically two types of derivations, leftmost derivation and the rightmost derivation. So let us first discuss the leftmost derivation. So in case of leftmost derivation, as the name suggests, the leftmost variable is being replaced by one of its production bodies, and it is indicated by arrow LM, which indicates the left derivation, and star LM indicates after many steps you have derived a particular string. So multiple steps are denoted by arrow and LM star. Okay, so that is what is the leftmost derivation. So you have to go on replacing the leftmost variable till you reach a particular string. Okay, so consider an example. Here the grammar given is E, comma, so E is your variable, plus star A are the symbols, P is the set of production rules, and E is the start symbol. So here are the production rules of the grammar. E gives E plus E, or E gives E into E, or E gives A. So these are the production rules, and we have to generate the string A plus A with the help of these rules and follow the leftmost derivation. So we will begin from the first production rule. So E gives E plus E. So with the help of first production rule we have got this rule. Then next we want to replace the leftmost variable. So here the leftmost variable is this one, this E. So first this E will be replaced by a terminal symbol, that is A. So with the help of third production rule, this A is replaced with the small a. So we will get the string E gives A plus E. Now which is the leftmost variable left? Now this is the E we are interested in. Now this E will be replaced by A. So we will be getting E gives A plus, now this E replaced to A using the production rule number 3. So this is the simplest form of derivation, that is the leftmost derivation. That is simply go on replacing the leftmost variable available to the terminal symbol. Now let us see the rightmost derivation. So it is just the opposite of the leftmost derivation. So here instead of leftmost, now the rightmost variable will be replaced by one of its bodies, one of its terminal symbols. So here it is indicated by arrow RM. The image is not clear actually, so it is arrow and RM which represents the rightmost derivation, and if there are multiple steps you have to show in a single step, then you can represent by using arrow star RM. Now consider the example. So same example, same grammar as we have used for leftmost derivation. So E is the variable, plus star A are the symbols, P is the set of production rules, and E is the start symbol. So same production rules are there, Now the string that we want to generate is a plus a into a, okay, with the help of this production rules. So we will be starting with the first production rule, e gives e plus e, that is the first production. Now we have to focus on the rightmost variable. So rightmost variable is this e. So replace this e with the product, because we are interested in a into a. Plus is already there, now we want into symbol. So which rule is giving that? Second rule. So we will replace the rightmost e with the second production rule, e into e. So we will get e is equals to e into e plus e into e. Right? Now focus on the rightmost variable available. Now this is the e available. Now we will be replacing e with a with the help of third production rule, that is e gives a. So we will get e is equals to e plus e into a. Now the rightmost variable is this one, e. Again it will be replaced with a with the help of production rule 3. Now the next rightmost is this e, which will be replaced by a further. So we will be getting the string a plus a into a. So this is rightmost derivation, that is we replace all rightmost variables with the terminal symbols in order to get the string. Okay, so these are the two types of derivations, leftmost derivation and the rightmost derivation. The next topic that we are going to study is the language of a grammar. So suppose if g is equals to v comma t comma p comma s is a context free grammar. Now this should be by heart. The four components together is nothing but the CFG, that is a variable, terminal, set of production rules and the start symbol. Okay, so if g of VTPS is a context free grammar, then the language of g is denoted by L of g. So language of CFG is L of g, and it is nothing but the set of terminal strings that have derivations from the start symbols. So from the start symbols, whatever strings you have derived will be the language of this particular grammar. So it is written as language of grammar L of g is equals to W in T star. What is W? W is the string formed with the help of symbols in T, such that S is the start symbol. S gives star on multiple steps on applying multiple grammar rules, that is G, and star indicates multiple steps. So multiple steps or multiple rules applied on the start symbol, you have generated the string W. So if a language L is the language of some CFG, then it is also called as context free language, because it is the language of context free grammar. So language of context free grammar is context free language. The next is the sentential forms. Sentential forms are nothing but the derivations that you have done from the start symbol, which produces the strings. So from start symbol you will be having the production rules, and ultimately you will be generating the strings. So these are called as the sentential forms. For example, if our grammar is G is equal to VTPS is a context free grammar, then S on multiple steps from the start symbol, if you apply multiple production rules and get a string alpha, then this is a sentential form. And if S arrow star LM, that is the leftmost derivation, after applying multiple leftmost derivations, if you get the string alpha, then it is a left sentential form. Also, if from the start symbol on applying multiple rightmost derivations, if you get the string alpha, then it is the right sentential form. So this is the end of the session. So in today's session we have studied the basics of context free grammar. Then we have seen the definition of the grammar. We have also discussed about the derivations. Then two types of derivations, referential and the derivations, that is leftmost and rightmost derivations. Then we have also discussed about the language of a grammar and the sentential forms of the grammar. So that is it for today's session. Thank you.